Now, before we move further, I want to distinguish the type of factor that subjects are from the type of factor that our treatment is. And this leads to the distinction between what are known as fixed and random factors. And this is a distinction that comes up because we'll be using a linear mixed effects model. Mixed effects refers to the fact that our model actually has two different types of effects, fixed and random effects. First, a fixed factor is where the levels of a factor are fixed. That is, the levels observed in the study represent the actual levels of experimental interest. For instance, in our wine study we're about to look at, the wines I've chosen are of actual interest. We want to know whether those wines differ from each other. And so if we were to replicate the study with totally different people, we would use the same wines. Those are the things we're trying to make an inference about. Now let's contrast that with a random factor. Levels of a random factor are known as random. That is, the levels observed in the study represent a sample from all the possible levels. So a random factor would be our subject factor. The subjects we have in this particular study are not the actual observations or actual levels that we're interested in. They're simply a sample of all the different possible levels of subjects we could obtain. So subject 1, remember I pointed out that judge 1 could be a strict rater. If I were to redo the study, the level of judge 1 I had the first time isn't the same estimate as I would have the second time. In the second study, that first judge wouldn't be the same person. I don't really care about the degree to which judge 1 differs from average. I simply need to estimate that in terms of my modeling. So the distinction between fixed and random factors really comes down to whether you're interested in the levels you've observed. For a fixed factor, we actually do care about the levels we estimate. So the toss of j's in our model are part of a fixed factor. We care about the degree to which wine 1 differs from average or wine 4 differs from wine 3. Those are the levels of interest. But our subjects are a random factor. Subjects are always random factors. They are a random subset of all the different subjects we could obtain. So a handy heuristic for this is, if you repeat the study, ask yourself if you would have the same levels of a factor. If you would, like for wine, that's a fixed factor. If you would have different levels, like different subjects, well, that's a random factor. So in our model here, judges will be a random factor and wines will be a fixed factor. Before I show you this diagrammatically, let me explain a little bit more what I mean about random levels and fixed levels. Now, to do this, let's think about the observations we have and what averages or means they'll yield. Let's first think about our observations for wine 1. Each of our judges will give us an observation, and so we'll have y-scores for each of those. Now, at the bottom, we'll have an average for wine 1. That is, across all the judges, there'll be some y bar, and this will be y bar dot 1. Next, for wine 2, we'll also have observations for each of the judges, and we'll have another y bar dot 2. For wine 3, we'll have the same situation, y bar dot 3. And finally, for wine 4, averaging across all the different subjects, we'll have y bar dot 4. So these levels of wines, that is, these y bars, are our fixed levels. If we were to reproduce this study and we were to make new estimates of wine 1, 2, 3, and 4, we'd be in essence trying to estimate the same thing in the population with each of these levels. All right, so now let's consider the judge rows. That is, each of our judges is giving us 4 observations, so actually we can compute a mean for each of our judges. Now think about what a mean for a judge really indicates. It's a judge's overall preference for how they're rating. Some judges will rate higher on average, and some judges will rate lower. So considering judge 1, the average across this judge's measurements will be y bar 1 dot. That is, the average of the different wines for judge 1. For judge 2, we'll have y bar 2 dot, and going all the way down, we'll have means for each of these judges. Now these are random levels. That is, y bar 1 dot, the mean for the first judge, won't be the same mean we would be estimating if we were to replicate the study. That is, the levels of judge 1 through judge 9 here are random levels. They're simply a random sample of all the possible levels that we could obtain from that factor. So again, that's the distinction between a fixed factor and a random factor. A fixed factor, like wine, represents observations that we are actually trying to estimate the levels of, whereas the random levels of our judges are representing not the actual things we're trying to estimate, but simply random levels from the subset of all the possible levels that exist out in nature. Now, the reason I make a point about this is our model is actually going to estimate these different terms differently. That is, we'll actually have to mark in JUMP judges to be random effects, because JUMP will model those as random levels. Now, our fixed levels will model as normal. That is, we've been modeling fixed factors this whole time with our regular analysis of variance. The only thing that changes is that our judges, since they're going to be a part of our model, need to be marked as random, so JUMP knows to estimate these in the proper way.